Welcome to Shell Scripting Basics. After watching this video, you will be able to outline what a script is, list use cases for scripting, describe the shebang interpreter directive, and create and run a simple Hello World shell script. A script is a list of commands that can be interpreted and run by a program called scripting language. Commands can be entered interactively at the command line or listed line by line in a text file. Scripting languages are usually not compiled. They are interpreted at runtime. Scripts are generally slower to run than compiled languages, but they are also much easier and faster to develop. Scripts are widely used to automate processes, such as ETL jobs, file backups and archiving, and general system administration tasks. You can use scripts for nearly any computational task, including application integration and plugin and web application development. A shell script is an executable text file in which the first line usually has the form of an interpreter directive. The interpreter directive is also known as a shebang directive, which has the following form: #bang interpreter plus an optional argument. Interpreter is an absolute path to an executable program, and the optional argument is a string representing a single argument. Shell scripts are scripts that invoke a shell program. For example, #bang/bin/sh invokes the Bourne shell or other compatible shell program from the bin directory. #bang/bin/bash shebang invokes the bash shell. Shebang directives aren't limited to shell programs. For example, you could create a Python script with the following directive: #bang/user/bin/env python3. Here we demonstrate how a shell script can be used to run a program with a simple Hello World example. From the command prompt, you can create a simple Hello World shell script as follows. Use the touch command to create an empty text file called helloworld.sh. The .sh extension is a convention used to indicate that the file is a shell script. Now, turn your text file into a bash script by echoing the bash shebang and appending that echoed text to your file using the double greater than symbol, which is the bash output redirection operator used for appending output to file. Finally, use the echo command to print the statement echo hello world and again redirect that output to your bash script. Before you can run your bash script, you need to make it executable. First, check the current permission settings of your script by using the ls command with the -l option. The R and W entries indicate that the script is readable and writable, but the lack of an X means it is not executable. The R, W, and X entries apply to 3 user-based permission groups: the owner, which is you, the group, and all users. You can make it executable for all users by invoking the change mod command with the +X option. Checking the permission settings now shows that your script is executable for all users due to the X entries for all 3 permission groups. Now you can finally run your bash script by typing /helloworld.sh and pressing enter, and the text hello world appears on the command line. In this video, you learned that a shell script is an executable text file that begins with a shebang interpreter directive. A shell script can be used to execute commands as well as run other programs. Scripting languages are not compiled, they are interpreted at runtime. And compiled languages may be much faster than scripting languages, but they also require more development time. Interpreted at runtime, and compiled languages
Welcome to Filters, Pipes, and Variables. After watching this video, you will be able to describe and use pipes and filters, and Explain and set shell and environment variables. Filters are shell commands or programs which take their input from standard input, normally the keyboard, and return their output to standard output, which is normally the terminal. We can think of a filter as a transformer, a program that transforms input data into output data. There are many examples, including word count, cat, more, head, sort, grep, and so on. The value of filters is that they can be chained together, which brings us to the pipe command. The pipe command, denoted by a vertical slash, immensely extends the functionality of shells. It allows you to chain together sequences of filter commands. The use pattern looks like this. Accordingly, the output of command 1 becomes the input of command 2, and so on. Not surprisingly, pipe is short for pipeline. For example, you can pipe the output of ls to the sort command with the -r option, which results in a reverse sorted list of directory contents. Shell variables are variables that are limited in scope to the shell in which they were created. Accordingly, shells cannot see each other's shell variables. You can invoke the set command to list all variables and their definitions that are visible to the current shell. Because it also lists a lot of subsequent information, you can pipe the output to head in order to show just the first 4 variable definitions. To define a new shell variable, simply use the equal sign to assign a value to your chosen variable name. Notice that there are no spaces around the equal sign. As an example, let's define a shell variable called greetings, which stores the string hello. To see the contents of the new variable greetings, use the $sign to access its value, then echo it back. You can display multiple variables as well. Let's define another variable, audience, with the value world. Then, echoing both variables back returns hello world. To clear a variable, use the unset command. For example, unset audience deletes the variable audience. Environmental variables are just like shell variables, except they have extended scope. They persist in any child processes spawned by the shell in which they originate. You can extend any shell variable to an environment variable by applying the export command to it. For example, export greetings makes greetings an environment variable. To list all environment variables, use the env command. Let's check whether greetings was exported as an environment variable by piping the output of env to grep and filtering the results using the pattern gree. Indeed, greetings is now an environment variable. In this video, you learned that filters are shell commands. The pipe operator allows you to chain filter commands. Shell variables can be assigned values with equal and listed using set. Environment variables are shell variables with scope extended to all child processes of the shell. Welcome to Useful Features of the Bash Shell. After watching this video, you'll be able to outline some key Bash Shell scripting features, learn about the characters and symbols in Bash Shell scripting features. Meta characters are special characters that have meaning to the shell. The pound symbol is used to include comments that the shell ignores. For example, this comment does not return anything. The semicolon is a meta character that separates commands typed on the same line. For example, these 2 commands return their outputs on 2 lines like this. The asterisk represents any number of consecutive characters within a file name pattern. For example, this expression returns all objects in the /bin directory with a name starting with BA and followed by any characters, which in this case is bash. And the question mark acts as a single character version of the asterisk meta character. For example, this expression lists all objects in the /bin directory having a single character in place of the question mark, namely the bash and dash paths. Quoting specifies whether the shell should interpret special characters as meta characters or escape them. You can use the backslash to escape the interpretation of a single character as a meta character. Here, the backslash tells bash to interpret the $sign as text rather than the default variable name, so the output is literally $1 each. Double quotes will interpret the text literally, except for any meta characters, which will be interpreted according to their special meanings. For example, the $1 expression without the preceding backslash is interpreted as a variable, which in this case is empty, as we see here. Notice that it printed the space before each. Single quotes, on the other hand, are used to interpret all contents as literal characters. For example, this expression returns the same result as the first example above. Input-output, or I/O redirection, refers to a set of features used for redirecting either the standard input, the keyboard, or the standard output, the terminal. The greater than symbol is used to redirect the standard output of a command to a file. It also creates the file if it doesn't exist, and overwrites its contents if it already exists. You can avoid overwriting by using the double greater than symbol, which appends the output to existing content. The combination to greater than redirects an error message to a file. To append the error message, for example, to an error log file, add another greater than sign. And lastly, the less than sign is a redirection that is used to pass file contents as input to the standard input. Let's look at a few examples. You can start by simultaneously creating a file and populating it with some text like this. You can then cat the file to see what's there. As you can see, line 1 was written to eg.txt. Now you can try adding another line to the file. And viewing the contents again, you can see that the file contains exactly the 2 lines you added. Entering something like the word garbage returns an error. This expression catches the error message and redirects it to the file err.txt, and indeed, the contents of err.txt is what can be expected. You can use command substitution to replace a command with its output. There are 2 equivalent notations. In the first, the command is encapsulated by parentheses with a $sign out front, while in the second, the command is encapsulated with backticks, also known as backquotes. Let's say you want to store the current directory path in a variable called here. You can use command substitution on the pwd or present working directory command to capture its output and assign it to the variable here. And indeed, echoing its value returns the current directory. Command line arguments are arguments used by a program specified on the command line. In particular, they provide a way to pass arguments to a shell script, a program. Command line arguments for a bash script are specified. The arguments arg1 and arg2 are passed to mybashscript.sh. Bash has 2 main modes of operation. Batch mode, which is the usual mode, runs commands sequentially. For example, these 2 commands, separated by the semicolon metacharacter, will be executed in a particular order. Command 2 only runs after command 1 is completed. In concurrent mode, commands run in parallel. The ampersand operator, after command 1, directs command 1 to operate in the background and passes control to command 2 in the foreground. In this video, you learned that metacharacters are special characters that have meaning to the shell. Quoting is used to interpret or escape metacharacter meaning. I/O redirection refers to a set of features used for redirecting. Command
Introduction to Advanced Bash Scripting. Refer to illustration. Cognitiveclus.ai logo, estimated time needed. 5 minutes in the hands-on lab portion of the final project, you will be using more advanced scripting commands and concepts that the course has not covered yet. This reading will familiarize you with these more advanced concepts so you can complete the lab with confidence. Objectives. After completing this reading, you will be able to create bash scripts that use conditional statements to run a set of commands only if a specified condition is true. Apply logical operators to create true-false comparisons. Perform basic arithmetic calculations. Create list-like arrays and access their elements. Implement for loops to execute operations repeatedly based on a looping index. Conditionals. Conditionals, or if statements, are a way of telling a script to do something only under a specific condition. Bash script conditionals use the following if-then-else syntax. Refer to the code example. If the condition is true, then bash executes the statements in statement block 1 before exiting the conditional block of code. After exiting, it will continue to run any commands.
Welcome to Scheduling Jobs using cron. After watching this video, you'll be able to schedule cron jobs with cron tab, describe the cron syntax, apply and remove cron jobs. Whether you're a system administrator or a data engineer or even a developer, there may be times when you want to schedule certain jobs to run automatically at certain times. For example, you may want to schedule a load script to run every day at midnight and a backup script to run every Sunday at 2 a.m. The cron utility on Linux and Unix-like operating systems allows you to do just that. Cron is the general name of the tool that runs scheduled jobs consisting of shell commands or shell scripts. Cron is the daemon or service that interprets cron tab files every minute and submits the corresponding jobs to cron at scheduled times. A cron tab, short for cron table, is a file containing jobs and schedule data. Cron tab is also a command that invokes a text editor to allow you to edit a cron tab file. Entering cron tab -E on the command line opens the default text editor. Using the editor, you can specify a new schedule and a command, which has the following syntax. Command can be any shell command, including a call to a shell script. The symbols stand for minute, hour, day of month, month, and day of week. All 5 positions must have either a numeric entry or an asterisk, which is a wildcard symbol that means any. For example, the following syntax means append the current date to the file sundays.txt at 15:30 every Sunday. Closing the editor and saving the changes adds the job to the cron tab. Let's take a closer look at each of these steps. Entering cron tab -E on the command line opens the default text editor. In this case, the default editor is GNU Nano. Conveniently, instructions for setting up cron jobs are included here as comments. Instructions for using the editor are also included, but you likely will only need Control-X in this context. Here, I have entered 3 example cron jobs. Notice that extra spaces are ignored, so to improve the readability, you can align your entries as columns under the header. The first entry instructs cron to append the current date to the file sundays.txt at 15:30 every Sunday. The next line specifies a load data shell script to run at midnight every day, while the last line results in cron running the backup data shell script to run at 2 a.m. on Sundays. To save the job, first type Control-X to exit the editor, and then enter Y to save your changes. The jobs are now in production. Running cron tab with the L option returns a list of all cron jobs and their schedules. I used tail to avoid returning all of the comments from the cron tab file. To remove a job, simply invoke a cron tab editor, delete the corresponding line in the cron tab file, and save the changes. In this video, you learned that cron jobs can be scheduled to run periodically at selected times. Cron, crond, and cron tab have different functions. Entering cron tab -E on the command line opens the default text editor. Running cron tab with the L option returns a list of all cron jobs and their schedules.
It's good.